Hello everyone. In this video we're going to talk about events and the relationship between events in random experiments. So we talked about random experiments and sample space, and we're going to take this example that you can see here, and this is spinning a roulette wheel. So if you've ever been in a casino, a roulette wheel is this wheel that you spin, and this little ball is going to land in one of these slots when the wheel stops, and is essentially a random experiment. And this random experiment has a sample space of this, right? All of these outcomes that you can see in this picture are the possibilities that can happen when the wheel stops. So every one of these is an outcome, and the set of all outcomes, as you can see here, is the sample space. Basically, we have 0 and double 0, and then we have 1 through 36. That's the sample space of this random experiment. Now, we're going to talk about events here. An event is a subset of the sample space. Basically, a portion of sample space that follows a certain characteristics or even does not follow any characteristics can be called an event. So for example here, red outcomes is an event, or black outcomes is an event. First 12 is a different event, or the third 12, or zeros. These are all different subsets of the entire sample space that you can see here. So for example, we can call the red outcomes or the red event R, and just show it with this letter R, which is in italicized font. So I'm gonna ask you to pause the video and write all the outcomes in this event. Event red and event first 12. Now, these are the outcomes that exist in this event, and it's a red and first 12. You can now think of many different events that are different subsets of the sample space, and these events can have some sort of relationships with each other. One of a very helpful and effective graphical way of showing these events is the Venn diagram. You might have seen Venn diagrams elsewhere, but what we see in the Venn diagram is this big rectangle that represents the sample space, basically the set of all outcomes, and events are basically shapes inside this rectangle. For example, here A is an event, which is a subset of the entire sample space, and then we shade that, basically signify the event of interest. So we're going to use the Venn diagram, and I always recommend you to use Venn diagram to graphically represent the relationship between events for yourself. The first relationship that we're going to talk about is the union of two events. Well, if you have two events of, let's say, A and B in this sample space, A union B is basically an event itself also that contains all the outcomes that are in either of the two events. Basically, the shaded area is A union B, and this is how you read it. And this is the sign that we use to show union relationship, and we read it as A union B. You can also read it as or. This is red or black, or red union black, whichever way you want to use. The other relationship that exists between events is an intersection. You can probably guess now that what is the intersection relationship. Intersection of two events is an event also that has all the outcomes that are in both of those two events. The shaded area here is the intersection of A and B. A intersection B, and this is the sign of intersection. You can also read it as red and first 12. Red intersection T1 or red and T1. And when two events do not have any intersection, just like what you see here in this Venn diagram, A and B do not have any intersection, we call them mutually exclusive events or disjoint events. What you can say about this relationship is that A intersection B is a null event. So this is not a zero. This signifies a null event or an empty set. An event that does not have anything. An example of that in the roulette wheel is that odd and even are two events in the roulette wheel example, and they don't have any intersection. Odd intersection even is an empty set. Another relationship is complement of an event, and we show that with A prime or A superscript C. And complement of an event is an event that has all the outcomes that are outside of that event. So basically this shaded area in this Venn diagram is A prime or A complement. So now I want you to pause and think about these two statements and see how you can fill the blank here. The first one says an event and its complement are, and this relates to A intersection A complement. The intersection of A and A complement is a null event because there is no intersection between the shaded area and the white area here. They don't have any intersection. So those two, they don't have intersection. This is null. And based on the definition that we had here, when two events do not have any intersection, they are mutually exclusive. So we can say mutually exclusive or disjoint, whichever terminology you prefer to use. The second one says the union of an event is complement. So union of A prime and A is basically both of them together. And that constitutes the whole sample space. Everything that is in the sample space is either in the A or in A prime. So when you union those two, you're basically covering the entire sample space. So that is sample space, or S. That's how we show it. There are some other rules that relates to the relationship between events. For example, a complement of a complement is the original event, right? Complement of a complement is A. And then we have De Morgan's laws. Basically, you can apply the complement operator to the individual pieces in the parentheses. If you want to apply that complement, it becomes A complement. This one also flips to intersection, and this one becomes B complement. Same with the other one. And then we have distributive law, which what you do is you expand these relationships, just like what you learn in algebra. In the next video, we're going to talk about probability. We get into how can we quantify randomness given the different events that we have in a sample space.